Hello everyone. Today the class number 49 for electrical machine 2. Class 49 for electrical machine 2. Okay. So in this class I will start the last module of your syllabus. The last module of your syllabus, that is the special machine. Okay. So make some heading: special machine, special electrical machine, special electrical machine. Okay. So in this special electrical machine you have to read that you have to study 4 different type of special machines. First one, write reluctance motor. Reluctance motor. Second one, write hysteresis motor. Hysteresis motor. Third one, write tacho generator. And fourth one, write stepper motor. Stepper motor. Okay. So these 4 modules, or these 4 special type of motors or machines you have. So first one, write the reluctance motor. So what is reluctance motor? Right. Reluctance motor is a single phase induction motor. Okay. Reluctance motor is a single phase induction motor. Right. First, which acts on the principle of the reluctance, which acts on the principle of the difference of the reluctance, which acts on the principle of the difference reluctance offered by the air gap in between stator to rotor. So reluctance motor is a special type of single phase induction motor which is used to uses the reluctance as a special parameter which is offered by the air gap in between stator to rotor. Okay. So reluctance motor. See, we are considering it is a stator of the single phase induction motor, and in this stator you can see here is a pole . Okay. Suppose we are considering it is a north pole and corresponding south pole will be here. Okay. So here you can say that it is A dash region and it is B dash region. Okay. So over it you have to apply some currents, right? You have to apply some wire which are conducting the amount of current. Okay. Suppose plus minus, or suppose DC excitation is given to here, or no need to write the DC. Okay. So just write Vs. Just write Vs. There is supply voltage is given to the stator, right? Supply voltage, first point, supply voltage is given to the stator, that is field windings. Supply voltage is given to the stator, that is field windings. Due to the supply voltage, due to the supply voltage, next write, due to the supply voltage and current IF, and current IF is flowing through the conductors, and current IF flowing through these conductors, right? When the current is flowing through the pole, when current is flowing through the conductors which is installed over the pole, when the current is flowing through the conductors which are installed over the poles, then induces and flux, right, then right, this flux is variable in nature, as because these fluxes are variable in nature, as because there are a difference in the reluctance, there are the differences in the reluctance in between the stator to the rotor terminals, in between stator to the rotor sections. Okay, so that means that means the reluctance offered by AA dash is this AA dash region is smaller compared to the reluctance offered by this AA dash region is smaller compared to than that of the BB dash, region. Okay, as because why? Because the air gap is more in between this section, that is BB dash. Okay, and the air gap is smaller compared to that is AA dash region. Okay, so when the rotor conductor, right, when the rotor conductor is aligned to the AA dash, when the rotor conductor is aligned, next point, right, when the rotor conductor is aligned to this AA dash region, then it offers less reluctance, that is maximum amount of flux will be linked, then the maximum amount of flux will be linked within this region AA dash, right? When a particular rotor conductor is superimposed over this AA dash axis, then what happen, or is coming to that axis, then what happen, then it will be experienced a more flux, that's phi max or phi 1 is experienced amount of flux phi 1, right? And when the particular conductor is aligned to that axis BB dash, then it offers another flux phi 2. Okay, then it offers another flux phi 2. So when this phi 1 and phi 2, there is a difference between two flux. Okay, when there is a difference between two flux is achieved, that is when the mismatching of the reluctance or flux, whatever you can say, the mismatching of the reluctance as well as flux is happened, then there will be a rotating magnetic field or rotating flux will be developed, then there will be a rotating magnetic field or flux will be developed inside the motor. Okay, inside the motor, and due to this fact the motor will rotate, and due to this fact the motor will rotate, that means due to the reluctance difference, the motor will rotate. But always remember, this rotation is a pulsating in nature, so but this rotation is pulsating in nature. So to start the motor, you have to need a auxiliary winding, right? As we know, for single phase induction motor, all time auxiliary winding is needed, right? For single phase induction motor, all time auxiliary winding is needed. That's why for this case also the auxiliary winding is needed, but here I am only considering only the field winding is present, main field winding is present. That's why it will produce a field, but this field produces the pulsating torque inside the rotor, right? So this field produces the pulsating torque inside the rotor. So that's why you cannot say that the reluctance motor will free to rotate inside the air gap without any auxiliary winding, but also there will be a must be present an auxiliary winding. Okay, so this is called the reluctance motor. And now next type of motor is your hysteresis motor. Okay, so next I will teach you the hysteresis motor. So wait for one time. One second. Okay, next one, hysteresis motor. So what is the hysteresis motor? First you have to understand what is hysteresis. Okay, first you have to understand what is hysteresis. Okay, so okay, first write it something, then I will discuss. Okay, so write it is a motor works on the principle of hysteresis. For production, it is a motor works on hysteresis principle for production of mechanical torque. The motor has no teeth. The motor has no teeth in rotors, no windings in rotors, and only cylindrical core is present inside the rotor. That means only if we consider it is a motor, then the stator field will looks like stator has no pole, right, and rotor has no teeth, and stator has no pole, no distinct poles, right, no distinct poles, right. A three-phase supply is given to the stator. A three-phase supply is given to the stator. A three-phase supply is given to the stator. It produces a rotating magnetic field. It produces a rotating magnetic field inside the air gap. It produces a rotating magnetic field inside the air gap, which magnetizes the rotor. Which magnetizes the rotor. Which magnetizes the rotor. And a corresponding rotor pole, a pair of corresponding rotor poles are generated. Instantaneous pole. There will be a generation of instantaneous pole inside the rotor. Okay, there will be a generation of instantaneous pole inside the rotor, and this pole is generated by lagging by the acute angle del from the rotating magnetic field. And this lagging of the pole is due to the fact of hysteresis loss inside the rotor. So as because this rotor is completely ferromagnetic material, so there will be a hysteresis, right? As because the rotor is completely forms or completely made up of a ferromagnetic material, then what happens? Then it will experience a hysteresis, and due to this hysteresis loss, there will be a lagging from the stator magnetic field to the rotor magnetic field. Okay, so that means for this case the rotor will chase. Rotor will chase the stator rotating magnetic field, and simultaneously the stator rotating magnetic field and the simultaneously stator rotating magnetic field will drag the rotor. That means what happened? Inside this hysteresis, due to this hysteresis loss, this lagging happens, right? The lagging of the flux produced by the stator and the rotor will be generated. And when there will be a lagging in between two fields, then what happened? There will be a relative motion in between these two fields, stator field and rotating magnetic field. a stator magnetic field and the rotor magnetic field, right? So then there will be a this type of phenomenon occurs. Then the rotor will try to chase the rotating magnetic field, which is rotates inside the air gap. Right, rotor will chase the rotating magnetic field, and the rotating magnetic field developed by the stator poles will drags the rotor. Okay, so that means there will be a magnetic locking happens. There will be a magnetic locking happens, and due to this magnetic locking, the rotor will rotates in a constant speed. Rotor will rotates in a constant speed. Okay, so always remember, hysteresis torque is almost constant. Most important advantageous point of this hysteresis motor is that the hysteresis torque, that is the torque produced by this hysteresis motor, is almost constant. Okay, so this hysteresis motor is used in, right, the motor hysteresis motor is used in clocks, electric clocks, okay, or some toys and different type of devices which is less power rating, okay, which is a power rating is less. Okay, so then right, hysteresis motor can only applicable on not only right, cross the only, right, the hysteresis motor is applicable on both single phase and three phase supply. Okay, single phase and three phase supply system. Okay, so this reluctance motor and hysteresis motor is completed. So in next class I will complete the tacho generator and stepper motor. Okay, so today's class up to this much. So waiting for the next day. Okay, thank you.